My name is Greg Nichols, and I'm a subject matter expert with the Homeland Defense and Security Information Analysis Center. And today, we're talking about emerging technologies for personal ballistic protection gear and how these new developments are improving the health of warfighters. The type of protective gear that U.S. forces use on the battlefield can prevent or minimize the effects of combat-related injuries, especially from explosions and gunshots. According to a 2012 report from Belmont et al., explosions accounted for 74% of all injuries among deployed troops in Iraq and Afghanistan in a 5-year period covering 2005 to 2009. And Walker and colleagues also reported in 2012 that U.S. troops suffered more than 4,000 combat-related gunshot wounds from 2000 to 2009. The U.S. Army will be rolling out new protective gear in 2019, termed the Soldier Protection System. It will provide at least the same level of protection that current gear does, but is 26% lighter, according to the Army Times. Although this new system takes advantage of current technologies, let's talk about some emerging developments that may be used for the next generation of warfighter protection. 3 of the most promising new technologies for ballistic protection are advanced composite fibers, metal foams, and graphene. Most current ballistic protective gear is made of aramid fiber composites, such as Kevlar or Twaron, or high molecular weight and ultra-high molecular weight polyethylene. These composites consist of fibers embedded in a resin, but the fibers are actually what stop the bullets, so new research is focusing on how to pack as many fibers into the gear as possible. Emerging designs are also exploring the use of aluminum nanowires and carbon nanotubes to create even stronger composites. Research conducted in late 2017 at North Carolina State University has caught the attention of the U.S. Army. This new creation is an amalgam of metal foam and a metal matrix composite and was able to stop a bullet and cause it to fragment on impact. Finally, a novel product called graphene is showing a lot of promise in ballistic protection. Graphene is an engineered nanomaterial composed of a single layer of carbon atoms arranged in a hexagonal pattern similar to a honeycomb. According to the website Composites Manufacturing, it is 10 times stronger and 10 times lighter than steel. And research from 2014 by Lee et al. Shows that it can even slow down projectiles moving at supersonic speeds. Silk has always been an important element in protective gear because it's one of the strongest natural fibers in existence. Let's talk about some new advances regarding its use in protection. Silk is derived from silkworms or spiders. Recent advances have even made it possible to create artificial silk. Silk is almost always found in textile form. However, some new research from the NanoProduct Lab at the University of Pittsburgh is changing the way we think about silk.
In this paper, we work with a very interesting material, silk-based materials. These are natural fibers that humans have been using for thousands of years because of their unique properties, their unique luster and lightweight and pleasant feel. So they've been used for textiles for a long time. But there's a lot more to silk fibers than just their use for textiles. More recently, we've started to recognize the unique biocompatibility and biodegradable properties of these materials, and that opened the door for many biomedical applications. The issue is that if we want to use silk materials for biomedical applications, we don't want it to be in the form of fibers, but rather in the forms of films that exhibit interesting optical, mechanical, and electrical properties. So in this paper, we work on developing regenerated silk fibroin films, which are optically transparent and mechanically flexible, based on processing of these natural fibers, along with carbon nanotubes, where we leverage the interactions between the carbon nanotubes and the silk fibroids, combined with microwave heating and solvent annealing in order to tune their properties. Our work enables a high degree of tunability of the structure and properties of the regenerated silk fibroin films. And we're excited about taking this further in the future and developing both the science and technology aspects of creating these functional materials. So there is, from a scientific perspective, there is a lot more to do in order to understand the interactions between the nanotubes, the functionalization of the nanotube surfaces with the protein molecules. And from a technological perspective, or an engineering perspective, we want to develop the process, the manufacturing process for taking these cocoons of natural silk fibers and transform them into a functional, thin, transparent, and flexible materials.
Even more research regarding silk is under development. In 2017, a team of European researchers were able to reinforce spider silk by feeding a solution containing carbon nanotubes and graphene to spiders. Earlier this year, a commercial company, Craig Biocraft Laboratories, delivered ballistic panels made of a patented textile called dragon silk to the U.S. Army. Dragon silk is genetically modified spider silk that is actually produced by silkworms. These technologies don't just apply to humans. Canines play an important role in military operations and need protection too. Current armor for military working dogs and special forces canines is designed to primarily protect the chest cavity. In fact, Baker and colleagues reported in 2013 that thoracic injuries are the #1 type of injury in military canines, and unfortunately only have a 38% chance of survival. The technologies we discussed today can also be applied to canine armor, and HDIAC has performed research in this area and continues to work with multiple defense agencies on this important issue. Thanks for joining us today. As you can see, DoD is taking advantage of these technologies to improve warfighter protection. To find out more, check out the HDIAC website and don't forget to follow us on social media.